Okay, welcome back. Now our equations get just a little more complicated. So in our next example here, not only do we have something altering the angle, but it's altering it even more. So consider, for example, the equation here, cosine of theta over 2 minus pi equals, let's say, square root of 2 over 2. Okay, so we want to find our new range of values that match up with this new angle, theta over 2 minus pi. So start off again with our standard values here. And now I need to modify this angle theta here so that it becomes a theta over 2 minus pi. So it turns out that what I have to do first is take care of the theta over 2 part. So we divide everything here by 2 to make that a theta over 2. And then I need to bring the pi over. So subtract pi from everything. That gets me negative pi less than or equal to theta over 2 minus pi less than 0. So that now everything is in the acceptable range now. So we now have our acceptable range, which happens to be not within one full turn about the circle, but rather a half turn backwards, the other way only. So we write this up as cosine u equals square root of 2 over 2. We would need to find the reference angle, u sub r, which again, square root of 2 over 2 is one of our exact values, 0.707, which comes from the uh, cosine of 45 degrees, or pi over 4 in radians, which we need to be in. Again, by the way, if you are having trouble remembering these, you can always use this little trick. Put your calculator in degree mode and do inverse cosine of that stuff. Right. And that will give you the 45 degrees, and you'll just need to convert that over to radians. Unfortunately, with radians, you just have to memorize the values or, check the decimals. Yeah, remember what the decimals are for the different pi over 4 and stuff if you left it in radians. So that's something you can do there if you need to, if you're absolutely stuck. But it's really worth it to just memorize those exact values for pi over 6, pi over 4, and pi over 3. And so now we go find the angles that would match up with that. So, however, now we want values where it's positive. So first quadrant's out though, because the acceptable range, remember, is between negative pi and 0. So remember, reading our angles, it's clockwise, we give it a negative value. So those are the places we have to look. And of those, the only place where cosine would be positive would be in the fourth quadrant. So we throw in our reference angle, and if we're putting it in the fourth quadrant, so it's between 0 and negative pi, we would have to use just the one value, which is negative pi over 4. So that's the only answer, because third quadrant cosine is negative, and so that's unacceptable. Of course, first quadrant's out because that's not in our restricted range now. So we have just the one answer, negative pi over 4, for u. And then we can go back and set the original angle equal to that value. In this case, just the one value. So theta over 2 minus pi equals negative pi over 4. And then we solve that equation for theta. So that means we're going to have to add pi to both sides. And when we do this addition, we think of that as negative 1/4 plus 1. So we're going to have theta over 2 equal to 3 pi over 4. And then we need to multiply that equation by 2, right, to get theta finally by itself. And so it turns out we have just the one answer to this equation, and that turns out to be 3 pi over 2. 3 pi over 2. So again, the key idea here, as it was earlier, is to take our angle and adjust so that we have that new angle and we have its new constraints. I often choose to replace it with a dummy variable u. That way I can easily talk about reference angles and stuff like that. Find my reference angle and then put it where it needs to be in the quadrants that are allowed by my new range. This time it's less than a full turn. In fact, the full turn's out. It has to actually go backwards. And then once we find all the values that work, we set our angle equal to that to solve for them. So that is our process there.